Voltage drop has the ability to drastically affect all of our notification circuits. Let's take 2 minutes to learn more about voltage drop. So voltage drop is going to be based off of your wire resistance, and what voltage drop is a loss of voltage along the circuit. Now there are certain things that are going to magnify your voltage drop, such as smaller gauges of cable and longer runs. This is a very important aspect when we look at fire alarm design. NFPA 72 specifically states that you have to have your voltage drop calculation as part of your design documentation. Within the confines of Chapter 10 specifically states that all equipment shall operate at 85% of its nameplate voltage. Majority of the systems that we work on are 24-volt systems. 24 volts at 85% means the last device has to be receiving minimum 20.4 volts. This really only allows for a voltage drop of 3.6 volts on the wire. We see this affecting the notification circuit much more than anything else. If you don't have enough voltage going to your notification, your audibles may not be producing what they need to be producing. Your visibles may not work. So it's very important that we have that voltage drop calculation. So looking at our illustration here, I've got three different illustrations. I've got what we'll call 18 gauge at 500 feet, and you can see that at 500 feet, we're dropping somewhere around 2 volts on the wire. 22 volts are being ending up at the end of line device, meaning that we've got 22 volts. We're within compliance of the code. Everything's going to operate effectively. We step it out to 750 feet of that same 18 gauge, and now we're losing 3.6 volts on the wire. We're still receiving 20.4 at the end of line device. We're still in compliance with code, but we're starting to cut it really close. Step it out again to 1,000 feet, and now we're losing 8 volts on the wire, getting only 16 volts at the device. Is it going to work? Depends on the manufacturer. However, we're not in compliance with the code itself. So here's a sample voltage drop calculation. We've got a 24 volt notification circuit that's utilizing 16 gauge 2 conductor solid coated cable. The circuit is drawing 750 milliamps. What's our voltage drop? Well, the first thing that we got to do is we got to go to NFPA 70 and go to our Chapter 9 Table 8 Conductor Properties table. We need to identify the type of, or the gauge of cable that we're working with, which was 16 gauge, looking at is it solid or stranded, and lastly, is it going to be coated or uncoated? So we go over there, we look at 16 gauge, it's solid, it is going to be coated. Per 1,000 feet, 16 gauge is giving us 5.8 ohms, or 5.08 ohms of resistance. So, plugging it in. The resistance of our cable, we had 500 feet of 16 gauge 2 conductor solid coated cable. Because it is 2 conductor, we are looking at 1,000 feet of circuit distance. 16 gauge solid coated at 1,000 feet, 5.08 ohms. Our resistance is 5.08. We look at the current, 750 milliamps, convert that to amps, 0.75 amps. We're just going to plug in for Ohm's law, E equals I times R, I being our current, R being the resistance. Our current was 0.75 amps times 5.08 ohms. Our voltage drop is 3.81 volts. That's our drop. We're going to be holding our first ever National Training Conference in Las Vegas, October 15th through the 17th. We're going to have multiple training classes available for fire alarm and sprinkler. If you're interested in learning more, you can always log on to our website, nationaltrainingcenter.net/conference.